All right, we're going to finish up section 14.4 here with the second video. We are still solving trigonometric equations here. This time we're going to be solving equations generally, or finding all of the answers to an equation instead of just the answers from 0 to 2 pi. So, solving generally, we'll cover all of the real answers. We're going to use multiples of the period, and now remember that the period for sine and cosine and their reciprocals is 2 pi. The period for tangent and its reciprocal, cotangent, is just pi. So it says we're going to use multiples of the period and the idea of reference angles to help us out with this. Okay. So here's the general idea. If we find out that, for example, let's say, I don't know. Let's take one of the answers that we did here. Nah, a little too much. How about we just look at the answers to the equation cosine of x equals negative square root of 3 over 2. Let's say that's the equation that we're solving. Okay, a little bit simpler than the ones we've dealt with so far. So, and we're going to solve it generally. Okay, we're going to find all the solutions to this equation. Now remember, if we did if we were just using the definition of the inverse cosine, there would only be one answer, and that one answer would be in the second quadrant, because that's where cosine is negative, and we see that it would be 5 pi over 6 would be the answer to this. X would equal only 5 pi over 6 in that second quadrant. Okay, but when we want to find all the answers to this equation, or find the general solutions, we want to find every possible answer. So there's another angle in one trip around the unit circle that would solve this equation and be a solution for x, and that's 7 pi over 6, because it also has negative square root of 3 over 2 as its cosine value. Now I'm using this picture here. I don't want you referring back to this picture for every problem that you're doing, but in order to introduce this, I thought it would be a good idea to put this visual here, because you're going to be using the idea of reference angles and what quadrants are positive, which quadrants are negative for the given function. So cosine is negative in the second and the third quadrant, and we know that because it's cosine of square root of 3 over 2, we are looking for the angle that has the angles that have pi over 6 as their reference angle in those two quadrants. So our answers would be 5 pi over 6, move that out of the way, and 7 pi over 6, because we're in quadrant 2 and 3. Now, those are only two answers. What we know about reference angles and coterminal angles is that any angle that falls with a terminal angle right there, and any angle that falls with a terminal angle right here, will also be solutions to this equation. So what we can do is say, well, 5 pi over 6 is a solution, yes. But if I went all the way around from that spot, in other words, if I added another 2 pi, or 12 pi over 6, I would also have 17 pi over 6 as an answer. Or I could go backwards. I could subtract 2 pi. I could subtract 12 pi over 6 and have negative 7 pi over 6 as answers here. I could do the same thing with the pi over 7, or excuse me, pi over 7, 7 pi over 6. I could say, well, I could go back 2 pi, I could subtract 2 pi from that guy, and I'd have negative 5 pi over 6. I could subtract, or I could add 2 pi onto that, add 12 pi over 6 onto that, and have 19 pi over 6. I'm starting to get more and more angles that would all be solutions to that equation. Okay, if we were solving for this equation and trying to find all the angles, there's 6 of them that work for x. There's a lot more. So what we do is we say this. Well, we can wrap up all of these by just using the idea of what the period of this function is. One solution to this equation certainly is 5 pi over 6. But if I want to keep finding more solutions, I can just add 2 pi to it over and over and over again, or subtract 2 pi from it. Well, the way we cover that is by adding 2n pi, because that would be adding 2 pi and then 3 pi and 4 pi, or negative 2 pi, negative 4 pi, negative 6 pi. So it would keep giving me all the angles that would fall on this red angle right here. Okay, that would cover all of those angles. And if I want to cover all the angles that fall on that terminal side, then I would start with that 7 pi over 6, and I would add multiples of 2 pi. And we just write that like this. We add 2n pi. That means multiples of the period, or multiples of 2 pi. This is the solution, the general solution to that cosine x equals negative square root of 3 over 2 equation. That covers all of the solutions. So now notice one thing here. These two solutions, it was almost like we were solving it on the period like we did in our last video. It was almost like we were solving it on the period 0 to 2 pi. Then we just added 2n pi in order to cover all the solutions. Now that is generally what we're going to do. Sometimes we're going to be able to simplify that, and you'll see that in a second. So let's take a look at the examples that you actually have on your sheet here. Okay, for the general solutions, we're going to isolate the function. We're going to use the inverse function to get the angle and find all solutions in that 0 to 2 pi interval, just like we did before. So this is just like we did in the first video. But then for each solution, we're going to add multiples of the period. By multiples, we say n. Okay, that covers the infinite number of solutions. All integer multiples of whatever the period is. And remember, this period of sine and cosine is 2 pi. Period of tangent is pi. So what we do then is, because it's 2 pi, we use 2n pi. And because it's pi, we use n times pi with tangent. We add those to our answers. Okay? And then we'll simplify our answers if possible. Examples here. All right, so our first equation is 2 sine of x equals 1. So we're going to divide by 2 and get sine of x equals 1/2. Okay, and one trip around the unit circle. Okay, we're first going to find our answers from 0 to 2 pi. We're looking for where sine is positive. That would be in the first and second quadrant, right, where sine is positive. And we want a reference angle of 30 degrees, or pi over 6, because that's what the sine value, that's what angle has a sine value of 1/2. So I'm going to write, we want the angle pi over 6 in quadrants 1 and 2, at least to start, because that is where sine is positive. So that would be pi over 6 and 5 pi over 6. Those are the only two solutions here. Notice how we are not down in the third and fourth. This is not like we took the square root and we have the positive negative out in front of it. So one of our solutions is pi over 6. And this is one way to write this. You could just list this 2 with a comma in between it, but sometimes I like to use this bracket, kind of like a piecewise function. So we have pi over 6 plus 2n pi. That would cover all of the solutions of that first angle, and then all of the coterminal solutions that go along with it. Okay, but the other thing we're going to do is take that 5 pi over 6 and say, well, I could start with that one and also add multiples of the period to that guy. And that would cover things like 17 pi over 6 and so on and so forth. All right. So that's our final answer there. That covers all of the solutions to that equation. All right, in our next example here, we're going to subtract 1, which is negative 2, and then we're going to divide by 4, and negative 2 over 4 simplifies to negative 1/2. Okay, so we have cosine of x equals negative 1/2, which, I thought maybe that was one that we did before. Nope, a little bit different here. We're going to be in the same quadrants that we were in the first one, because cosine is negative in 1 and in 2, or excuse me, 2 and 3. I gotta slow down here. Can't think and change colors at the same time. All right, 2 and 3 are what we're looking for here. So our reference angle is going to be, what angle has a cosine value of 1/2? Well, that would be pi over 3. But we want to be in the quadrants 2 and 3. Okay, so in 2, reference angle of pi over 3, that means it would be short of pi by pi over 3. That'd be pi over 3, or excuse me, 2 pi over 3. And if we are in the third quadrant, the reference angle, a little bit more believable, reference angle of pi over 3, we're pi over 3 past pi, so we're at 4 pi over 3. Those are our two answers there. So x is going to equal those two answers. Now we need to just add our multiples of the period to each of those. All right, moving right along here. Example 6. We have the cosecant of x equals divide by, or add 2 divided by the square root of 3. Do a little rationalizing here. Multiply by the square root of 3 over itself. There we go. So cosecant of x equals 2 over the square root of 3. Well, that would be the same angle that has a sine value of the square root of 3 over 2, since that's been flipped right there. So what angle has a sine value of... I'm really looking for the angle that has a sine value of the square root of 3 over 2, which is pi over 3 again. Okay, but where do we want it to be? Well, this is positive. Okay, since it's positive and it's cosecant is just like its reciprocal sine, so we want to be in the first and the second quadrant. So we're going to be in quadrants 1 and 2. Okay, so we're going to have pi over 3 in quadrants 1 and quadrants 2. So let's take a look at those answers there. So we have pi over 3 would be one solution. There it is in quadrant 1. And we would have 2 pi over 3. And we just need to add our multiples. I don't know why I don't do that when I have my first color. There we go. There's our solution. Okay. So these are what our answers are starting to look like here. And again, you can just list them with commas in between them too. You don't have to use the bracket. All right. Last example here, unless if we do a little exploratory thing afterwards. Let's see what we got for time. This is a lot like the ones that we did on the front side, in the fact that we're going to take the square root here. So let's start getting that function isolated. Add 3 and divide by 9 to get 1/3. I'm going to take the square root, which, don't forget, gives us positive and negative. So right now you know that you are going to be in all 4 quadrants with this. The square root of 1/3 is 1 over the square root of 3, which rationalizes to the square root of 3 over 3. Okay? So, and if you ever don't, if you can't remember what is what, make a quick, if you don't have it already, make a quick table to help you out. Okay? Oops, pi over 3, it was right the first time. So we know that this is 1/2 and 1/2. This is square root of 3 over 2. Square root of 3 over 2. We're looking for the angle that has a tangent value of 1 over the square root of 3. We'll look at what sine divided by cosine would give us right there. It would give us 1 over the square root of 3, which is the square root of 3 over 3. So this is the angle that we want. We know that x is going to be pi over 6, and because of that positive or negative, we're going to do it in all 4 quadrants. In all 4. Okay, so now, something special is going to happen here. Okay, we said up above in our notes we want to simplify our answers if possible. Think about what our answers are going to be here. One of our answers is going to be pi over 6. Another answer is going to be, pi over 6, not pi over 3. Pi over 6. Our next answer in the second quadrant is going to be 5 pi over 6. In fact, I'm going to write that right there. Our next answer in the third quadrant is going to be 7 pi over 6. And our fourth answer in the fourth quadrant is going to be 11 pi over 6. Those are our 4 answers. Now, we don't, in this case, just want to slap that plus 2n pi after all of them, because we can simplify this. Notice, trying to make this kind of obvious by making the same colors, that I can get to, from my very first answer of pi over 6 to that 7 pi over 6 simply by adding pi. And I can get back to that pi over 6 again by adding pi. So I can cover both those answers in the first and third quadrant by just adding multiples of pi instead of 2n pi. So that's what I'm going to use as one of my answers. Pi over 6 plus n pi. Okay? Oh, actually, probably should slow down here a little bit and realize I'm dealing with tangent. I probably shouldn't have been thinking about 2 pi to begin with, because the period for tangent is pi anyways. So really I shouldn't have been thinking about adding pi, but I guess what we notice then is I don't need to write a second equation that says 7 pi over 6 plus n pi, because it's all going to be covered in that guy. The only other equation I need, and we're going to start with the smallest angle possible, is 5 pi over 6, and we can get from that answer to that answer by just adding pi, and then back again by just adding pi, and that would cover all those blue answers. So these are the answers to this equation simplified. I'm not listing all 4 of them out because I don't need to. The red ones are covered with that first red one, and the blue ones are covered with that first blue, or that second blue and green one. So that is the simplified form of that answer. I'm going to show you one more case. I know we're getting past the 15-minute mark in the video, and some of you are starting to probably find different videos to watch here now. Something more exciting than solving trig equations. Let me take a look at example 2 on the front side. We're going to take a look at example 2, which was solving on the interval, and we're going to change it to solve generally. Okay, we already have all the work done for us here. Okay, we have the 4 answers in one trip around the unit circle. But now I want you to think about the idea that, okay, it's sine, which means normally we'd add 2n pi to each of those, but that wouldn't make sense because I can simplify that. Now this one's even easier to simplify than the other one. Or I don't know if it's easier, but we can simplify it even further. Instead of just saying, oh, I can get from this one to this one, and then back here, I can actually get from pi over 4 to 3 pi over 4 by adding pi over 2, and notice that that is the same thing that I would add here. Pi over 2, and so on and so forth. And I could just keep getting all of the answers by adding pi over 2. So if we wanted to solve this thing generally, if we were asked to find all the solutions to this guy, we could just say that it would be x equals simply pi over 4 plus multiples of pi over 2. You could write that as n pi over 2. You could write it as pi over 2n. Any of those versions would work, or you could do it in other ways too. 1/2 times n pi. I kind of like this because it simplifies the fraction. This covers everything. If this were a solve generally problem, that would be our only answer. Pi over 4 plus multiples of pi over 2 would cover the infinite answers to that problem, and that is how you would simplify the general solution for that problem.